Okay, we're back. It was a nice breaking point because this part is kind of boring. I actually find it to be mesmerizing. I wanted to say something about the number of rays. There will be one more ray than segments that we dropped here. So I had 8 segments, so I got 9 rays. You need to kind of count them a little bit so you don't mess up. This is 1, 2, 3, 4, 5, 6, 7. So I'm looking for the eighth one. 1, 2, 3, 4, 5, 6, 7, 8. And I'm looking for where it intersects. It's going to be this and this. And notice I've gotten rid of some of these lines after I get rid of them right away. Oh, so they don't mess up. And then the ninth one. The ninth one I don't have to count because it's the last one. And I want this last intersect between here and here. And that is my last segment of my funicular. All right, now it's clear that I have not satisfied the boundary conditions. I'm going to save this just for fun here. Funicular and forces 2. You should save your work. But it's easy to satisfy the boundary conditions just by moving things around, right? So I'm going to move this around until I have something that reasonably looks, and you could fuss with this if you want and just get it to drop down right about there. That's fine. Okay, so now I've passed through the crown. I was looking at the crown and I'm looking at the right. The left is absolutely fixed. And notice it's not a semicircle. Now it's kind of close to a semicircle, but it's not a semicircle. The other super cool thing is that I could immediately change the span here, for instance. I can make it 100 feet and everything changes automatically because it's a parametric program made for little kids to learn geometry and algebra. The other great thing is I could change the rise. So I talked to you about Teshima Art Museum a little bit. I think it's ridiculously shallow. So 100-foot span, maybe a 12-foot rise, right? Oops, what happened there? The rise was 12. How do you make that happen? You have to increase the forces a lot to make it a lot. But even there, it's hard to tell the difference between that and the circular segment. Now this ray, the length of this ray is the length of the longest force. Remember, this is the force diagram. So I will find this ray that is called segment Q for me. Segment Q. It has, and you could actually find segment Q with a number in here. It's 36.87. But don't type in 36.87 because it changes.